So under the terminology, our next term is the degrees of freedom. Degrees of freedom refers to the number of value involved in the calculation that have the freedom to vary. So these are those values which includes in the calculation and that have the liberty to vary. It is very important to calculate the degree of freedom because the number of degree of freedom always helps to determine the critical value, means p value, at which you can accept or reject the hypothesis. So degree of freedom is very much important to calculate the critical value, and the formula to calculate the degree of freedom we generally used degree of freedom is equal to n minus 1. Here n is the number of observation. So it is the basic formula for the degree of freedom. Now we will see according to the test it will change. Like if we are doing test on one sample, like for the one sample t-test, the formula for the degree of freedom is n minus 1, means total number of observation. If we are having the 5 number of observation, then 5 minus 1. So degree of freedom will be 4. If we are taking two samples, like we are taking one is the control group, the other is the experimental group. So if we are taking two samples, then the formula for the degree of freedom is n minus 2. Okay, n is the total number of the both sample minus 2. Then if we want to calculate the degree of freedom for the chi-square test, these are the tests that we will study later on. Chi-square test degree of freedom is calculated by the r minus 1. R is the number of total rows in the contingency table into c minus 1. C is the number of total column in the table. So row minus 1 into column minus 1 helps to calculate the degree of freedom. And if we want to calculate the degree of freedom for the ANOVA test, then degree of freedom between the group will be number of group minus 1. If we want to calculate the degree of freedom within the group, okay, then number of subjects minus number of groups minus 1. So this is the various formula to calculate the degree of freedom. So next term is the p-value. P-value means probability value that is used in hypothesis testing. It helps to support or reject the null hypothesis. So actually the p-value is act as the evidence against the null hypothesis. So on the behalf of the calculated p-value, we can either reject the null hypothesis or we can support or accept the null hypothesis. So the smaller p-value, if we have the smaller p-value, then we have the strong evidence that we can reject the null hypothesis. And if p-value is larger, then we cannot reject the null hypothesis. Okay, when we run a hypothesis test, we compare the p-value with our alpha level. Means we compare the p-value with the alpha level like 5% or 0.05 or 1% or 10%. So already determined alpha level is compared with the p-value. So if p-value is less than the alpha level, then we can reject the null hypothesis. And if we see graphically, the p-value is the area in the tail of the probability distribution. Okay.